Hello chemistry students, this is Nico, and in this Science of Nico, what we're going to be doing today is we're going to be taking a look at calculating pH. This is an essential skill that you need to be right on top of when we're talking about the chemistry of acids and bases. Now, when we're talking about calculating pH, there's a few things to take note. Okay, so we're talking about the equilibrium between water and hydrogen ions and hydroxide ions, okay, and how acids and bases affect that equilibrium of a solution. So if we have an acid that's going to add more hydrogen ions to solution, likewise if we have a base that's going to add more hydroxide ions to solution, and that will affect the overall pH of that solution. Now, of course, when we're talking about acids and bases, we are really talking about forming hydronium ions. So there's a little bit of simplification going on in many places. You're going to see discussions about acids and bases when we talk about pH. But just take note, that's just people using a simpler form of talking about these relationships between these substances. Now, the other thing to note is that our pH scale is a log scale of the hydronium ion concentration from 0 to 14. And just take note, on that scale, pH 7 is neutral, below pH 7 is acidic, and above pH 7 is basic. Okay, so when it comes to calculating pH, we use the following expression to do so. All right, the following equation. So pH equals minus log of the concentration of hydrogen ions. All right, and so if we use that in terms of an example just here, if we were to find the pH of a 0.1 mole per litre hydrochloric acid solution, okay, we would need to take note of the following things. Notably, that hydrochloric acid is a strong acid, which means we have 100% ionization. All right, so that means our concentration of HCl is equal to our concentration of hydronium ions. And so our concentration of hydronium ions is 0.1. All right, so we would take our 0.1, we'd plug it into our minus log hydronium ion concentration equation. Now take note with your calculator, I'll just bring this up just here, that we're talking about log to the base 10, and so that should be log as in log of wood. There is also natural log, that's a different function on your calculator, so just be mindful that you know that you are using the correct log when you are using your calculator to calculate these values. All right, and that's fairly straightforward, and that will give a pH of 1 in this example. All right, it's time for a challenge. All right, we're gonna make this one a little bit harder. And our challenge is to calculate the pH of a 0.02 mole per litre sulfuric acid solution. And there's a little kicker here, you have to assume that there is complete ionization. Now you take note that there are 2 donatable hydrogens in sulfuric acid. And so that means that you need to work with that when you calculate your pH. So just remember, this is a challenge. So the idea is you hit pause, have a go at doing this question at home, and once you're ready, hit play and I'll go through it with you. All right. Don't forget, hit pause. Okay. Let's take a look at our answer just here, okay? Now, so with these styles of questions, the best way to solve a calculation question in chemistry is to, just at the side here, write down your data. So we have sulfuric acid, we know that's diprotic. All right, so what that means is our hydronium ion concentration is actually going to be twice the concentration of the acid, because each particle of acid can donate 2 H+ ions to our water molecules to form our hydronium ions. So 2 times 0.02 will give our concentration of hydronium ions as being 0.04. Likewise, all right, we can take our 0.04 and we can plug that into our minus log 10 pH calculation, which will give us a value of 1.3979, okay, which we can round down to 1.4 in terms of its pH. All right, so that's how you do these calculations. They're pretty straightforward overall. All right, now that's how you get to pH. But what if you already have pH and you want to work out the concentration of hydronium ions? Well, we can do that too. All right, and to do that, we use the following expression just here. So our hydronium ion concentration being indicated by these square brackets around the chemical species, can be found by taking 10 and putting it to the power of the negative pH. So for example, if we have a pH 4.5 nitric acid solution, we can work out the hydronium ion concentration in terms of moles per litre by taking our pH 4.5 and putting 10 to the power of minus pH 4.5, which will give us a value of 3.16 times 10 to the minus 5 moles per litre. Alrighty, let's finish ourselves off with one last challenge just to wrap this up. Okay, and that challenge is if we have the pH of an aqueous solution of hydrochloric acid, alright, and that was determined to be 5.8, what is the concentration of hydrogen ions in this solution? All right, so just remember this is a challenge. Hit pause, give it a go at home, and once you've done that, hit play and I'll go through the answer. All right, don't forget to hit pause. Okay, let's go through that answer. Now again, remember, always work with your data. That's the first thing you do. So going from the question, all right, we have a solution of hydrochloric acid, which is monoprotic. Okay. All right, and it's also a strong acid, so it's going to have 100% ionization, and the solution has a pH of 5.8. Now, here, if we have our hydrogen ion concentration, we take our pH of 5.8 and we put 10 to the power of minus 5.8, we will get our concentration in terms of moles per litre of 1.6 times 10 to the minus 6 moles per litre, being our hydronium ion concentration. Okay, now of course, just to finish this off, it's a good idea just to put your answer and label it appropriately as what you're trying to find. Okay, so that's how you do that challenge. All right, that's how you find your hydronium ion concentration. Alrighty, so just quickly in review. Alright, so in this video what we've done is we've taken a very quick look at calculating pH as well as calculating the hydronium ion concentration from pH values. There is more to pH calculations and we're going to explore those in some later videos. Alright, but for now that's a good introduction for how to actually do it, and it should be a fairly quick introduction. Thank you for watching. Alright, if you have any questions, feel free to ask those in the comments below or in class. Bye.